In the last video, we have seen about I2C and SPI. So SPI advantage I already told, but again I'll repeat it. So advantage of SPI, it is faster than asynchronous serial transmission, and the receive hardware can be simple shift register. It supports multiple slaves. Okay, the disadvantage of SPI is it requires more signal line than other communication method. The communication must be well defined in advanced, and the master must control all the communication. It is usually requires separate signal select line to each slave. Okay, so the next one is universal asynchronous receive transmit. So in universal asynchronous receive transmit communication, uh, it communicate directly with each other. Like two universal asynchronous receive transmit is communicating directly with each other. So the transmitting UART convert parallel data from a controlling device like a CPU into serial form, uh, transmits it in serial to the receiving UART. Means UART1 will transmit the data to UART UART2. So which then converts the serial data back into the parallel data for receiving device in the receiving device. Only two wires are needed to transmit data between two UART. So data flows from the TX pin of the transmitter UART to the RX pin of the receiving UART. So UARTs transmit data asynchronously. So which means there is no clock signal to synchronize the output of bits from transmitting UART to the sampling of the bits by the receiving UART. So instead of the clock signal, the transmitting UART adds start and stop bit to the data packet being transferred. So these bits define the beginning and end of the data packets to the receiving UART knows when to start reading the bits. When the receiving UART detect a start bit, it start to read the incoming bit at a specific frequency known as the baud rate. The baud rate is a measure of the uh, speed of data transfer expressed in bits per second. So both UART must operate at about the same baud rate. The baud rate between the transmitting and receiving UART can only differ by about 10% before the timing of bit gets too far off. So here we have TX line and RX line. So parallel data will be converted to serial, and serially it is going to transmit through TX line, and in the receiver side it will receive through RX line, and again it will convert that into parallel data. So we can see here we have 4 bit of data. The data is given is like now 7. So loading after giving a clock signal, the 7 will be transmitted. So after transmitting, like bitwise it will transmit. So finally after 4 clock signal, it will transmit all the 4 bits. Now if I want to transmit 5, it will transmit that. So after 4 clock pulse, we will receive 5. Okay. Um, so in 1 second, how many clock pulses applied? So that is the bit rate, and the baud rate is the number of variation in high and low signal. That is the baud rate. So it should be same for UART communication. So the next topic is one wire interface. So in the one wire interface, as in the block diagram we can see, there is only one line is there to transmit the data for more than one slave. So data out from the port pin is directly connected to slave 1 and slave 2. Okay. So in 1994, the application note explained that the only serial port interface option for one wire device with microcontroller port pin uh, or UART and UART based communication port. Since that time, special driver chip have been developed for direct connection to UART, PC bus or USB port. Meanwhile, the number of one-wire device also grew to a long list. These various development made it necessary to update the earlier documentation. Instead of merging the specifics of all the relevant information into a single document, this new document refers the reader to other application notes whenever possible. So the first one-wire devices, the DS199X series, were published in SRAM technology. Next, the non-volatile EPROM technology become available, and the DS198 and DS 250X series devices were released. These EPROM devices need a 12-volt programming pulse and are not erasable. The next leap forward was EEPROM, electrically erasable programmable ROM technology, which allows programming and is erasing at 5 volt or less. So electrically erasable programmable ROM technology is found in DS197X and DS243X and DS28EX series device. To ensure proper power, electrically erasable programmable ROM device may need a master that support storing pull-up, a feature that temporarily bypasses the one-wire pull-up resistor with a low impedance path. The extra power is needed for write cycle, and in case of the DS1977, also for reading. So beside electrically erasable programmable ROM device, the strong pull-up also uh, powers one wire temperature sensor and special functions such as SHA1 engine, which is found in secure one wire device. Temperature logger, the I button, use SRAM technology and therefore do not have any special external power requirement. So the general information about the one wire is the only voltage based digital system that works with two contexts, data and ground for half duplex bidirectional communication. Half duplex means two-way communication, but at a time we cannot transmit and receive. So same time we cannot transmit and receive. We can transmit the data and we can receive the data, but at a time only one operation can be done. A one-wire system consists of a single one-wire master and one or more one-wire slave. The one-wire concept relies both on master that initiates the digital communication and self-timed one-wire slave device that synchronizes to the master signal. The timing logic of master and slave must the measure and generate a digital pulse of various width. When it is idle, a high impedance path between one wire bus and the operating voltage puts the one wire bus in the logic high state. Each device on the bus must be able to pull the one wire bus low at the appropriate time by using an open drain output. So if a transaction needs to be suspended by for any reason, the bus must be left in the idle state so transaction can be resumed. So this is about one wire interface. The next one is parallel port. So in the parallel port, according to the block diagram, we can see there the data line. So depending on how many bit data we are want to transmit, that many lines should be connected from the master to slave. So if and there is a address bus also required. So address bus, depending on how many bit address, that many address lines is required, and how many bit of data, that many data bus is required, and two more control signals, that is read and write signals are required. So whether to write into the slave device or whether to read from the slave device. So the parallel port is a type of interface where parallelly data will be transmitted. So the parallel port is a type of interface found on computer for connecting peripherals. The name refers to the way the data is sent. Parallel port sends a multiple bit of data at once. In parallel communication, as opposed to serial interfaces that sends bit uh, one bit at a time. To do this, parallel port required multiple data lines in their uh, cable and port connectors and tend to be larger than the contemporary serial port, which only requires one data line. So there are many type of parallel ports, but the term has become most closely associated with the printer port or printer port found on most personal computers from 1970s. Though the uh, through the from 1970. So it was in industry refactory factory standards for many years and was finally standardized as IEEE 1284 in the late 1990, which defined the enhanced parallel port. So and enhanced extended capability port. So bidirectional version, it is extended capability port, that is a bidirectional version. Same data line can be used for transmit and receive. So today the parallel port interface is virtually non-existing because of the rise of USB device along with the network printing using Ethernet and Wi-Fi connector printer. The parallel port interface was originally known as parallel printer, parallel printer adapter, or on IBM PC compatible computer. It was primarily designed to operate printers that used IBM 8-bit extended ASCII character set to print text, but could also be used to adopt other peripherals. So graphic printer along with the host of other devices have been designed to communicate with the system. So we'll try to understand this with so we can see here for serial communication the bytes the bits of any 8-bit data, it is like low LSB bit will be transmitted first, and after that next bit. So like that, one bit at a time will be transmitted to that line. But for parallel communication, we are transmitting, or if there is a 8-bit of data to be transmitted, then there is a 8 lines for transmitting that 8-bit data. So same time, same instant of time, all the 8-bit data will be transmitted. So the conversion from parallel to serial and serial to parallel is not required. So this is what the advantage of parallel communication. Next is external communication interface, and this we will discuss in the next video.